Alrighty, so next up we have a dilation. A dilation, this is the only one that changes the size of it. It gets bigger or smaller. The others are all congruent. These will be similar. And we're going to practice that concept of congruent and similar after we get done with dilations here. So, similar figures, first off, is a figure that have the same shape, but not necessarily the same size. Okay? And we're going to make a list here of our congruent and proportional parts. Congruent, remember, same shape, same size. So, congruent parts are the angles. The angles stay congruent. The shape doesn't, the size doesn't change on the angles. It's the proportional parts are all the sides in here. And I'm not going to list them off here. We'll have plenty of practice at that. But again, the parts that stay congruent are the angles. The parts that change size are the sides. Okay, so we've talked about the congruency statement before. Now we talk about the similarity statement. Remember, congruent, same shape, same size. Similar is same shape, different size. So it's a statement where corresponding congruent angles of the similar figures are listed. So in this case, remember, order matters. A, B, C, D, E, F. A, B, C, D, E, F. And that tells us that angle A is the same as angle D. Angle B is the same as angle E. Angle C is the same as angle F. Notice there's no equals part underneath of it. So before, when we did congruent, we had the tilde with the equals. That's not the case. This time it's just the tilde. That's what it's called, the little squiggle there. You can call it a squiggle, I don't care. Tilde is, I think, T-I-L-D is how it's spelled. Alrighty, so a dilation. The transformation that results in a size change. The pre-image and the image are similar. Again, not congruent. They are similar. So in this one, this one shrinks, right? Probably the origin, I'd imagine, on this one. And it'll give you a point. It'll shrink to here. But again, I'm sorry, this one expands. I said it backwards. I do apologize. You can tell because A prime's always the after, right? Pre-image and image. So A becomes A prime. It expands out. C becomes C prime. It expands out. B becomes B prime. It expands out. And you can see here, right? Each one is bigger in this case. So what you do need in a scale factor, in a dilation, is you need a scale factor and you need a center. So a scale factor is the number that describes a size change. It can get bigger or smaller. The image divided by, and it's again divided by the pre-image. So it's really easy to calculate. That's what I'm trying to spit out. Image divided by pre-image. And so that's a fraction, right? So image, that's the second one, right? Divided by the pre-image. Your scale factor. So what that looks like in this case, the number, so let's start here. This one obviously got bigger because the pre-image, the A, right, B, C, D, is smaller than A prime, B prime, C prime, D prime. This one, we can see the center, it explodes out from A. So A and A prime are the same point. And again, we're going to practice this. So it goes from 4 to 8. It gets bigger. So this would be a scale factor of 2, right? So again, the image, which in this case was, I'm going to change colors here, was 8. The pre-image side was 4, so 4 and 8, right? Scale factor is 2. Just divide it out. The other one over here gets smaller because, again, we see the E, F, G, H is bigger than E prime, F prime, G prime, H prime. Prime kind of slid off the G there. So it got smaller. And the center, right, is at C, so it shrinks down to C. Again, to get the scale factor, I start out with my the image, which in this case was 4. And the pre-image was 12. And we reduce the fraction, which becomes 1 over 3. So my scale factor is 1/3. So it's not tough to calculate. I just got to remember that the image, the after, right, is divided by the pre-image, the before. That's the hardest part of this, in my opinion. I almost mix this up sometimes too.